Good morning, students. Today we are going to discuss about the fourth chapter, transistors. Semi in the semiconductor devices, we are going to discuss about the transistors. So what we need to learn here is first we invented the PN junction diode. After getting the two terminal device PN junction diode, what we are getting is the PN junction diode is acting as a switch. In the forward bias it is on, in the reverse bias it is off, and it is used for the AC to DC conversion, and it is also used for the clipping, clamping, that is wave shaping purposes, switching purposes we are using. After that we invented the another semiconductor device, three terminal device, that is the transistor. What is the use of transistor? Why we are using this transistor means the main and important use of this transistor is amplifier application. This transistor is act as the amplifier as well as the switch. So that is the main importance of the transistor. Amplification means if we have any weak signal, that weak signal should be strengthened by using the transistor. The weak signal is going to become a strong signal without changing its wave shape and its frequency. That is the advantage of the amplifier. So that's why the importance of the transistor is very important. After inventing the transistor, the total electronic industry changed vastly. The total electronic industry is changed. Now we try to discuss about this transistor in detail. So introduction to the transistor. So what is a transistor and so on. The transistor was invented in 1947 by Dr. John Bardeen, Dr. Walter Brattain and Shockley at Bell Laboratories in USA. So that is the invention at the 1947. From the 1947, the electronic industry is developed vastly. It is the invention of the transistor that has brought revolutionary changes in the field of electronics. The invention of the transistor that has brought the revolutionary changes in the field of the electronics. Whatever the present electronic goods are there, all these goods are because of the transistor only. So this is a scientist which are invented Bardeen, Shockley, Brattain. So what is the transistor form? You can see transistor is an acronym for transfer resistor. So what is actual transistor means? Transferring the resistance. Transfer the resistor. So the transistor having the three terminal. So in the three terminals, one terminal may take as a common terminal. The first one and common terminal is used as an input. The common terminal and the other terminal is used as an output. The signal is transferred from the first input side to the output side. How we make this input and output is made as a high resistance and output is made as a low resistance terminals. So the signal transfer from the high input resistor to the low input resistor, that is the transferring the signal from high resistance to the low resistance. That's why it is called as a transfer resistor. The transistor is an active device. Transistor is a semiconductor device made of germanium or silicon. The transistor may be um, the transistor may be made of with germanium and silicon. We generally used semiconductor materials are silicon and germanium. So this manufacturing also same thing. So basically the transistors are two type. The first one is the bipolar junction transistor. The name you can say that BJT, bipolar junction transistor. Another one is the field effect transistor. The second one is the field effect transistor. Bipolar junction transistor means in the bipolar we use the two type of charge carriers. That is we can say charge carriers are positive and negative electrons and holes are there, free charge carriers. So in the BJT we use the both charge carriers, minority charge carriers and majority charge carriers for the conduction. That's why it is called as a bipolar. Junction means it having the junction, with having the PN type junction is there. That's why it is called as a bipolar junction transistor. Field effect transistor. The field effect transistor means applying to the external field, we decrease or increases the field. The current flow or the output is depends on the field. So that's why it is called as a field effect transistor. Field effect transistor FETs. So first we try to discuss how the formation of transistor, that is a BJT, formation of transistors. From the previous chapter, you got an idea about PN diode. Yes, you know that P-type material, N-type material, both material are combined together. Whenever P material and N material combines, the junction is formed. That's why it is called as a PN junction diode. P-type material, N-type material, and we having the junction. So that's why it is called a PN junction diode. Basically, transistor consists of two back-to-back PN junctions. We can assume like that. Basically, two transistor consist of two back-to-back PN junction diodes manufactured as a single piece of semiconductor crystal. You can see diode 1 and diode 2. The arrow symbol indicate the N type, so that is the P, N, N, P. So the back-to-back connection we get the three terminals. Okay, positive terminal or negative terminal or positive terminal, may anything. That is the two diodes back to back. You can also combine the reverse also. Depending on this type of combination, we have two type of transistors are there. You can see. So like this, we establish the three terminals. Combining two diodes, we establishing the three terminals. These two junctions gives rise to three regions. We can say that is emitter, base and collector. Emitter, base, collector. Whenever we combining this, so what we are getting, you can see emitter E, base B, collector C. These are the three regions, and these three are the terminals for that particular regions. Emitter, base and collector. So now we can see a junction transistor is simply a sandwich of a thin layer of one type of semiconductor material. between two layer of other type of semiconductor material. What is the meaning is a junction transistor is simply a sandwich of a thin layer of one type. You can take any thin layer, N type or P type, on semiconductor material between two layers of other type of semiconductor. If you use N, that is a PNP transistor. If you use the P, that is a NPN transistor. So like this, we having the two transistors are there: NPN transistor, PNP transistor. So already you need what is the use of this emitter base collector. Why we are giving these names for emitter base collector. What is the meaning of emitter means? Emitter having the width is high compared to the base and collector. Emitter is doping is very high. Emitter is heavily doped, moderately sized. Heavily doped means it need to generate the free charge carriers. That's why it is heavily doped. Base is only the platform to transfer the charge carriers from emitter to base, emitter to collector. That's why it is the lightly doped and thin. The size also thin. Coming to the collector will collect the all charge carriers from the emitter and base. So that's why doping is moderate, and the width is the very high compared to the emitter and base. Like that, the size is also specifically specified: emitter, base, collector. Emitter will emit the free charge carriers, base carries the free charge carriers, and collector will collect the all the free charge carriers. Now we try to see the symbol, transistor symbol, how it is. First we can taking the in reverse back to back connection NP and PN. What happened? We are getting the NPN. If we directly connect PN, we get the PNP transistor. You can see these diagrams, and you can also draw NPN transistor, PNP transistor. So the current, how the arrow symbol we are giving also, that is important. The notation always the conventional current flows from P to N. So that's why arrow is from the P. You can see in the middle P to N, and it indicates the emitter terminal. The arrow on which terminal the arrow symbol is there, that is the emitter terminal. NPN, PNP. So we have the two P terminals here. You can take any one. That is called as a emitter, which having the arrow symbol, that is the emitter. These are the symbols of transistor. Generally, junction transformers, bipolar junction transformers are two type. Bipolar junction transistors. Bipolar junction transistors are two types. One is the NPN transistor, another one is the PNP transistor. So now we try to discuss about the transistor symbol. You can see how it is. The simplified IC NPN transistor. NPN transistor IC, how it is. We are having the collector contact, emitter contact, and base contact. We have NPN, like that. We are having the this is NPN or PNP. Thus width also is here, how it is 0.001 inches N. The total is 0.150 N. Formation of PNP transistor: emitter, base, collector. One now can see the figure. What I show in the figure shows thin layer of N-type material thin layer of n-type material sandwiched between two layers of p-type material. It is a NPN transistor. A thin layer 0.01 inch thin layer sandwiched in between the two p-type material. So this is the formation of NPN transistor, a thin layer of p-type material sandwiched between the n-type material. So that is called as a NPN transistor. Very simple. The figure showing an NPN transistor consisting of a thin layer of p-type material sandwiched between two layers of n-type material. Sandwiched between two layers of n-type material. These are the different package types we have in the transistor. Generally used three terminal transistor. You can see we have the three terminals. To identify emitter, we having the notch is there. To identify that, we having the notch is there. From the notch, we can by using the clockwise or anti-clockwise, we can make that emitter base collector. That's way we identify. The thing is here, notch means some of metal come outside. That like that you can see there. So that indicates the notch emitter base collector in the clockwise direction. If you go for the anti-clockwise, collector base emitter, like that, emitter collector base, we can get that. The two junctions gives rise to the three regions. We have the two junctions. Why? Because in the p material we inserted the a thin layer of n-type material. So first we get the p to n junction and to p junction. We have the two junctions. The two junctions gives rise to the three regions. The two junctions gives rise to three regions. The middle region is called base, and the outer two regions are called as the emitter and collector. The thin layer which we are sandwiched between the material, that is called as a base. Remaining outer layers are called as the emitter and collector. Three terminals were taken from three regions, namely emitter, base and collector. Three terminals were taken from three regions, namely emitter, base, collector. Although emitter and collector are made of same material, their functions cannot be interchanged because they have different physical and electrical properties. The two materials, that is emitter collector, both are formed with the same material, but the difference is that both having their own properties. That is, although emitter collector are made of same material, their functions cannot be interchanged. Their functions cannot be interchanged because they have different physical and electrical properties. Emitter, what it makes? Emitter is that region of the transistor which emits majority charge carriers into base region. Emitter, it is that region of the transistor which emits majority charge carriers into base region. The next one is the doping concentration. The doping concentration of emitter is more than both base and collector. Already we discussed the doping concentration of emitter is emitter is more than both base and collector. More base and collector. It is the region of the transistor which emits the majority charge carriers into base region. Base region. Next one is the base. So you can say what is the base means. It is the middle region of the transistor which we inserted very small thin layer. It is the middle region of the transistor. It is very thin and lightly doped as compared to either the emitter or collector. What is the meaning? This layer is very thin in size and lightly doped in doping level with compared to the emitter and collector. The main purpose of base is only carrying the charge carriers of emitter to the collector. It does not alter the flow of the charge carriers. It is the arrangement that to transfer the charge carriers from the emitter to collector. The last one is the collector. The collector is the region. It is that region of the transistor which collects the majority charge carriers. Purpose of the collector is collecting the charge carriers emitted by the emitter passing through the base region. Emitter purpose is it should emit the charge carriers. Base purpose is it transfer the charge carriers. Collector purpose is which collect all charge carriers which are emitting or which are coming from the emitter and base. That is the property of the collector. Collector region is made physically larger than emitter and base. Collector space or collector physically larger than emitter and base because it should collect all the charge carriers, so it need to have the space base to despite the heat generated by high velocity charge carriers dissipate the heat generated by high velocity charge carriers. The meaning is whenever we are collecting, if any charge carriers dissipates the heat energy that may dissipated from this high, that it is physically larger size region. Its doping concentration is greater than base region and less than that of the emitter region. So doping concentration also is different from other layers, that is less than emitter and greater than the base region. The PN junction between emitter and base is called emitter junction. The junction in between emitter and base is called the emitter junction, and the junction between base and collector is called the collector junction. We have the two junction, emitter base junction, collector base junction. The horizontal lines represents base while the two inclined lines represent the emitter and collector. You can see in the symbol, you already seen that the horizontal line represents the base B, while the two inclined lines represents the emitter and collector. Emitter is distinguished from the collector by an arrow. So we have the three terminals. So generally we say that in the middle terminal is the base. There is no ambiguity in between that. The problem is how we need to identify emitter and collector. Both are same material. We don't see which having the size, which layer having the more size. We can't visible that. To identify that specific emitter terminal we having, if we identify emitter base collector, like that we can identify the three terminals. So emitter is distinguished from the collector by an arrow. By using the arrow head, we distinguish the emitter from the remaining two. Arrowhead on the emitter represent the direction of conventional current, and arrow, but not only the identifying the emitter, it indicates the conventional current direction. Conventional current means the current always starting from plus and ending at the minus. It starts from the plus, so it's towards the plus. It's towards the plus. In PNP transistor, arrow points towards the base, meaning that emitter is at the positive terminal potential with respect to the base. PNP, always P to N, so that's why the emitter enters into the P. A PNP transistor arrow points towards the base, meaning that emitter is at the positive S with respect to the base, positive with respect to the base. In NPN transistor, arrow points from base to emitter. The meaning is that the base collector as well is at positive potential with respect to the emitter. The base is emitter and the base is at positive potential with respect to the emitter, like that positive to negative. Always that arrow indicates positive to negative side. We have the two transistor, NPN transistor and PNP transistor. Now let us consider the PNP transistor biased for active operation. So now we established a device which having the three layers base, or we can say emitter, base, collector. We having the three terminals, emitter, base, collector terminals, and we having the two type of layers, NPN one type transistor, PNP another type transistor. Now we try to discuss the what happened in the device when we apply the biasing. We try to discuss this biasing term. We already discussed in the last class. Biasing means applying the external DC voltage. Applying the external DC voltage to the device is called as the biasing. What is the purpose of biasing means applying the biasing, we know how the device is behaving. For the what input, what output we are getting. So why we use this biasing means to study the characteristics and also to make the device on a proper position, proper operating position, means at what voltage the device is acting as our required application, at what voltage the device is satisfying our application. So we need to provide that voltage. So that type of thing called as the biasing. Now we see the active biasing. We try to discuss what are the different biasings are there for the PNP transistor or NPN transistor. For understanding, we use one thing, one of the transistor, any PNP transistor, how it is working. Now we try to discuss PNP transistor. You can see the transistor biased for active operation, P type material, N type material, and you can see the another P type material. we have the three terminals. First, emitter, base, collector. You can see emitter terminal, base terminal, collector terminal. The junction p type, p and n junction is called as the emitter junction. N p junction is called as the collector junction. Because the base is common, that's why emitter junction we are calling, and we are also calling the collector junction. You can see the diagram also represent the width and the concentrations of the layers. You can see emitter is the layer which emits the free electrons, and the doping layer concentration is more, so that's why the p layer is filled with the majority charge carriers. What are the majority charge carriers? In the p material, holes are the majority charge carriers, and electrons are the minority charge carriers. That also indicated is here. Number of holes are more, the number of electrons are very less, only dotted lines are the electrons. Coming to the base, already we know that base is a very thin layer, so same represented here, very thin layer and very lightly doped, so that's why we having the light concentration of electrons are there. Majority charge carriers are electrons, minority charge carriers are holes. Coming to collectors, the dimensions are very high. Why? Because it need to collect all the charge carriers that is indicated in the space. You can see the width is high compared to the emitter and collector. The doping minority charge carriers and majority charge carriers also mentioned there, and also currents also mentioned here. P type material, what we indicated that always current passing from the P to N. P to N means that is the junction, emitter junction P is here, P2 it is going, and again collector to P2 is comes outwards, and from N means N should be what you say, you can enter IE, who can say IC, IE is enters, maybe is outgoing. So generally it may have different ways. You can see what we are doing is we are applying the external voltage VEE, VCC. So and what way we connected is P type material is connected to the positive, and this N is connected to negative for the emitter junction. This is called as forward bias. Emitter junction is forward bias. This side is here, collector junction is reverse bias, that is P is connected to negative, N is connected to the positive, so that is nothing but a negative, that is a reverse bias. Emitter junction is forward bias, collector junction is reverse bias. In this we have like that, we may have, now we can see. So what he try to, you see here, free electrons, the filled bubble is the free electron, that is a hole. You can see electron recombination with the hole. And next, so you see how it is going. So what happened means, from the p type material, the hole is going to junction and it is recombining. So what happens, majority carriers cross the emitter junction and becomes minority carriers. What happens, majority charge carriers moving and becoming the minority charge carriers. Once again you can see, so all the majority charge carriers are moving into the base like that, and again majority carriers moved from the emitter will further moved into the collector, like that they are increasing. So minority carriers generated due to thermal temperature cross the reverse bias collector junction. Now we see minority charge carriers. So like that, what happened means emitter junction is forward biased and collector junction is reverse biased. Recall why the transistor is called BJT, bipolar junction transistor, because its operation depends on the flow of both the majority carriers as well as minority carrier. Why? Because if you see the emitter and the collector is the majority charge carriers, coming to the base it means the minority charge carriers. That's why its operation depends on the flow of both the majority carriers as well as minority carriers. Hence, its name is the bipolar. The forward bias emitter junction is there. Emitter junction causes the majority charge carriers holes from P type to cross the emitter junction. First, what happens? Forward bias at emitter junction causes the majority charge carriers, that is the holes from P type to cross the emitter junction. Emitter junction constituting for emitter current IA. Next, the emitter current consists of holes crossing from emitter P to base N and electrons crossing from base to emitter. Electrons crossing from base to emitter at junction E. Almost all the emitter current IE consists of holes. Do you know why it is? In the N-type base, as it is slightly doped on thin 1% to 2% of holes entered from emitter recombined with few electrons. This recombination results in base current. In the N-type base, as it is lightly doped and thin 1% 2% of holes entered from emitter recombined with few electrons, this recombination results in base current IB. The remaining holes 99% to 98% entered into the collector region, that is since collector region is reverse biased, constitute part of the collector current IC and the remaining IC from minority carriers. The whatever the remaining holes entered into the collector region constitute part of the collector current IC and the remaining IC from minority carriers. The thermal generated minority charge carriers in base and collector constitute for reverse saturation current or leakage current. The thermal generated minority charge carriers in base and collector constitute for reverse saturation current or leakage current ICBO at collector junction even without forward bias at emitter junction. The collector current consists of the fraction of emitter current IE and the reverse saturation current, that is the collector current equal to majority current alpha IE plus ICBO. Alpha IE plus ICBO. Let us consider the NPN transistor biased for active operation as shown in figure. So this is the NPN transistor. In the last we discussed about the PNP transistor. NPN transistor, emitter junction, collector junction. Here the majority charge carriers are electrons. You can see NPN and direction is there. From the emitter we are getting the 100% of emitter current is passing, but in the P, because of P, some of the electrons are 2% of electrons and holes are recombined The 2% may draws here. Remaining 98% are at the collector junctions. It reaches to the collector junction. Here also we need to connect the emitter junction is in forward bias, collector junction in reverse bias. Emitter junction means N means we need to connect minus, P means we need to connect the positive. So this is a forward bias, and the collector junction is reverse bias. N is for plus, P is for the minus, as shown in the figure. So once again we try to discuss. Emitter junction is forward biased and collector junction is reverse biased, as I mentioned. The forward biased emitter junction causes the minority charge carriers electrons from N-type emitter to cross the emitter junction. Emitter junction constituting for emitter current. The emitter current consists of holes crossing from base to emitter at emitter junction. Almost all the emitter current consists of electrons. We know almost all the emitter current consists of electrons. In the p-type base region, 1% to 2% of electrons injected by the emitter combine with few holes. This recombination results in base current IB. The reverse bias at collector junction causes the N-type collector to collect the 99% to 98% of electrons emitted by the emitter. These are majority charge carriers in NPN transistor. These are majority charge carriers in NPN transistor. There are thermally generated charge carriers in the base and collector regions. There are thermally generated charge carriers in the base and collector regions, which are minority charge carriers constitute for reverse saturation current. So this is now we try to discuss about the transistors currents in NPN transistor. What are the currents are there? We know already. ICBO means the minority carriers current from collector to base. The minority carries current from collector to base when the emitter is open. The reverse current is temperature dependent. It gets doubled for every 10 degrees rise in temperature. The meaning is, for every 10 degrees rise, ICO becomes the doubles. The collector current consists of a fraction of emitter current and reverse saturation current. Fraction of emitter current plus reverse saturation current, that is given by IC equals to alpha IE plus ICBO. IC equals to this is the majority carriers, that is the minority carriers, we know already. Though transistor can perform number of other functions, its main use lies in the amplifying the electrical signals. So like this, we having the majority current and the minority current is there. So until in this class we discussed about the formation of the transistor. So generally what we classified is transistors are two types. First one is the BJT, bipolar junction transistor. Second one is the FET, field effect transistor. In this class we try to discussing about the BJT, bipolar junction transistor formation, how BJT is forming. So whenever we connect the two diodes back to back, if we connect the two diodes back to back, we can get the three regions. Those three regions are called as the transistor. So depending on the connection, we having the two type of BJTs are there. First one is the NPN transistor, another one is the PNP transistor. So the transistor having the three terminals, three region, the name given as the emitter, base, collector. So emitter will emit the charge carriers, base will carries the charge carriers, and collector will collect the charge carriers. Whenever you make the transistor in active condition means we having the two junctions in the transistor, emitter junction and collector junction. If we make the emitter junction in forward bias and collector junction is reverse bias, the majority charge carriers from the emitters moves towards the base. Some number 2% or 1% to 2% charge carriers are recombined in the base. Remaining 90% of charge carriers, because of the emitter junction, because of the collector junction is reverse bias, the minority charge carriers of the base enter into the collectors. Like this, the current is moving from the emitter to collector. So here we using the two charge carriers in the emitter, majority charge carriers, in the base, minority charge carriers. By using both charge carriers, we are transferring the current from one to another. So that's why it is called as a bipolar. And here we having the junction, we having called a bipolar junction transistor, bipolar junction transistor, BJT. So that collector current in this having the collector current is nothing but a fraction of the emitter current plus the minority charge current, that is the ICBO, reverse saturation current, ICBO. So it gives the currents of the transistor. In the next class, we try to discuss about remaining of the transistor. Thank you.